And I have just uploaded this on Canvas, on files, Fernando's class. I have uploaded this, or I have opened this folder, final project, Educatorium. It sounds like biblical, but it's a building. And this Educatorium is the building that we're going to study today. I have a PowerPoint, a PDF presentation, and plan section. So today we will open Revit, and we will introduce this plan section building. As you can see, this is not very accurate, and we only have this reference. The distance between these two red lines is 5 meters. Well, we are using meters because this is a European building, and well, the measurements are taken in meters. Does it make a difference? I don't know. We can use feet because I don't want to be very accurate when it comes to dimensions, um, because I want you to have different buildings. So I don't want the same file. So if at the end of these 4 or 5 weeks you end up having the same building as your neighbor, that means that you have copied. So I'm just giving you this reference. This is 5 meters, and then you have to guess the rest of the dimensions. And I don't mind. 5 meters is around 15 feet, kind of. And well, as you can see, this section, it's complicated. We have ramps, we have a wall, or we have a floor that has a slope, and then it's folded and it becomes the ceiling or the roof of this part of the building. And at the same time, this is the roof, but we extend this slab, and this is the floor. Okay, so this is a building that will, yeah, we will have a lot of, we will learn a lot of Revit features that we can do with this. How to create ramps, how to create, well, let's open the file. Okay. This is the picture of a building, and well, this is it. It's, do you see a straight line? Well, probably we don't have any straight lines here. We have tilted curtain walls. We have this element that it's folded, and here is the floor, but here it becomes the roof. And we have overlaps between this shape and that shape. And here we have a window opened on this curved surface. Well, it's as I told you, it's not a. We have to understand this building, and then we have different structural elements here, and that's another excuse to talk about structures. Okay, because when we are working with single-family houses, we have just walls, and since the span between two walls is not too large, structure is not relevant. But when we are working with public buildings like the TDS Center, the spans between structural elements, it's quite big, and we don't see here because we have a false ceiling. But in different parts of the building where the structure is exposed, we see that there are like huge steel beams, and there will be steel columns somewhere. Okay, so this building, since it's not a common building, we don't have straight lines or parallel and perpendicular lines. So we have these kind of things. There will be different structural elements, and we will model these different structural elements. And by modeling this, I think you will get to know more about structures. Okay, so this is the main view. We have this corner. This is a street. This is another street, and we have this corner here. This building is very famous in Europe. The architect is a guy by the name of Ren Koolhaas. It's not Koolhaas, it's Koolhaas because it's from the Netherlands. Well, this is the guy. And if you look at pictures, well, we can see what this guy has designed. What are the most famous buildings by this guy? There's a lot. This is in Seattle. In this building, it's the Seattle Public Library. It's something outstanding. This building. Okay, but as you can see, they're not regular buildings. So they're not common boring buildings. We don't have straight lines. We have a lot of shapes, and we adapt structural elements to those shapes. This is a skyscraper. I think this is in China. Yeah, I think it's in Beijing or Shanghai, I don't remember. But again, this is a skyscraper, but something different. Okay, it's not the skyscraper, the straight tower that we are used to. No, this is something, it's something different. And I love this building. I've been here. This is in Porto, in Portugal. This is an auditorium, an opera house. And let me find more. Porto Opera House. So again, it's something special. It's like it has like a diamond shape. We don't have straight walls, but at the same time, it's very simple. And but this building is outstanding. I was there. I wasn't very fond of this guy of red colas, but when I visited this building, I changed my mind because it was quite good. And if you look at the plan of this building, it might look very complicated, but if we look at the plan, okay, when we see the plan, we understand the building very well. So what is an auditorium? An auditorium is this big hall, and then we have the service areas, the vertical communication, elevators and staircases. And by looking at this, we understand, okay, so this is the element, the main element of the building. This is the main hall, and the opera house. So we have the stage here and the seating area. And then, yeah, we have this weird shape that when we are looking at the section, we understand everything. So this is the big element. So we can understand this element in this section, in that section, and in the plan. Okay, so in the rest of the spaces are small spaces around this big space. Okay, so the rest of the thing, even if we have this weird shape, but well, we can create nice lobbies here. But if we look at the sections in the plan, I think we can understand this easily. And the most important space is always this the auditorium itself for 4,000 people. But the plan is not difficult to understand. And that's the secret to this kind of architecture. So you might think, okay, it might be impossible. So look at this. We have a building. We don't have any straight line in that building. Okay, but this is just the envelope. If you analyze the building, we do have straight lines because the gravity is important here. And we need, if we have straight columns, things will work well. Okay. Well, so I like this building, but when he was young, or when I was young, when I was younger, I remember when I was studying, this guy was like booming. It was in the 90s, and everybody was talking about Red Colas. Red Colas, wow. He was in the Netherlands, and every single architecture student that I knew at that time wanted to go to work for free for this guy. And they did it. So they showed up there in Rotterdam, or I don't know, or probably in Amsterdam. I don't know where his company was. Okay, Rem, I am your admirer, and I want to work for you for free if it's necessary. He's like, okay, go ahead. And so I have a lot of friends that if this, and a lot of young European architects, they wanted to learn from him at that time. Then he became famous, and he worked all around the world, and especially in China. But what else can we? The Porto Opera House, the Seattle Library. Okay, it's always something special. Um, we might like it or not, but we have to. Yeah, so it's something special. In this building, I haven't been to Seattle, so I have never visited this building, but I would like to because it's something special. And what else? Hmm. Yeah, when he was started, he was obsessed by these kind of shapes like eggs. Can we call this an egg? Yes, I think we can. Okay, so if you find this shape, probably is a building by Rencolas at the beginning of his professional life. Well, eggs. Eggs have something special. W, eggs. I think I've shown you before some works about Salvador Dali, a surrealist painter, and he was obsessed with this shape because it's like the egg is the secret to the life. What is a okay, so we have this, and when he designed his own, uh, what is this? This is a tomb. Well, he's buried here in this building, and he's a museum as well, and everything has to do with eggs. Yeah, because it's the origin of life. It's something like very physical. Eggs. Anyway, this guy was obsessed with this shape, but it lasted only like 5 or 6 years. Then he developed his style, and he started doing something. Anyway, he's very interesting. I think he has the best website I've ever seen for architects. By the way, the website is OMA, OMA. Okay, it's outstanding because it's very simple. But what is it? It's the OMA of his work, and we have big pictures. Okay, and here we will find the projects or yeah. So here there's a list of projects starting in 2021. Prada. Yes, I don't know why, but he's the official architect of Prada, and he has in New York City, Prada, New York. New York. Yep. So we have this shop in the Fifth Avenue, and it was designed by this guy. Again, it's something special. We have this floor that becomes like a sitting area, and it's like a stage. You open this, you have like a stage for. Uh, it's always something fun and different. The things that you can even for this is a shop. It's not a huge space. It's just a shop. It's in the Fifth Avenue, New York, but it's just a shop, shopping shopping area. Anyway, go over this guy because this is probably the most influential architectural firm for sure in Europe, but I think all over the world. He has worked all over the world, and this is in New York City as well. This is a very interesting. Here we have, this is New York, and we have two outstanding examples of contemporary architecture, of 21st century architecture. So this one is from Ren Koolhaas. As you can see, he repeats his, yeah, so we have this diamond shape many times. And this is, I think this building here is from Sana, New York. Yep. I'm talking about the building because the architect is Kazuyo Seiba. So, yeah, this is Kazuyo Sejima. She's a Japanese architect, very good. And again, something special. So she designed this building in New York, and you see that there used to be another building here, and now Ren Koolhaas has demolished that building, and they have a new one. Well, we might think that I like this better than the new one. Having two buildings so close to each other, it's like, why? Anyway, this guy or this girl or this lady, Kazuyo Sejima, she has another outstanding example of contemporary architecture, and this is very close to King. This is in Connecticut. This is, what's the name of, this is the Grace Farms. Okay, yeah. Grace Farms, Connecticut.
I think I've done that.
Sorry?
I think I've done that.
I didn't hear you.
I think I've done that.
You've been there?
Yeah.
When?
Like a while ago.
Because this building was built like 2-3 years ago.
Never mind. There's a nice piece of architecture in Connecticut that I was thinking of. My bad.
But I think if you have been there, you should remember this building because it's something unique. Maybe you have been to Grace Farms, but did you see this building?
Wait, yes, I did.
Okay. It's something unique. I mean, if you've been here, you remember. Yeah. So it's very simple. So we have this shape, but it's just a roof, and that's it. It's a roof that it's adapting to a slope because it goes slightly up or slightly down, depends. And well, something very simple, very minimalistic, but quite interesting. So if you haven't been there, try because it's not well, it's not far from here. Maybe it's 2-3 hours from here, but it's worth visiting this building. Well, we were talking about Kazuyo Sejima and Ren Koolhaas. And if you're interested in nice architectural presentations, visit this website because it's very good. It's very simple, but it's very good. It's just a way to display, or if you are looking, or if you want to create your portfolio, or I don't know. I like this website. Okay. Well, this is an introduction to Ren Koolhaas. He has yeah, we all have had little moments. And now we are looking at the Educatorium. So the Educatorium is something that he designed in the early 90s. I think when I was a student, that building was already built, as far as I remember. And well, it was one of their first buildings. It's quite interesting as well. You can look at it. Maybe you okay. I don't like it. Well, maybe we don't like it, but there's something that okay catches the eye. What is this? How can I do that? What is this transparency? There's something. There's a volume here, but this volume is transparent. We have structural elements here, and they are exposed. We have columns, we have tilted columns here. How can I do that? So because this building is interesting and we can take good screenshots of this building, we're going to analyze and then we're going to do it. There is a lot of information. We have physical models, we have 3D models, so we can take a lot of information from this building. And yeah, we will be looking at different aspects. And since it's something weird, yeah, we will learn features, Revit features to create these kind of shapes and to create these kind of openings or these tilted curtain walls. So there's a good opportunity to learn. But first we need to understand the building. So this is the first goal. And finally, we will end up creating this kind of axonometric views. We know how to do these axonometric views now for the ground floor, the first, the second, and the third floors. Because I think in this building, it's necessary to divide the building in different slices so that we can understand what we are doing, probably in plan and in section as well. Yeah, so this is the ground floor, and this is the first floor with these two auditoriums here. And well, if we look at the plans, probably this is the ground, the first, the second, and yeah, we only have 3 floors: the ground floor, the first, and the second floor, or the first, second, and third. But if we understand these 3 floors, I think we're all set. And since we have ramps, because this building is based on ramps, so we have ramps to go from one floor to another floor. This is what we have to understand at the beginning. But other than that, it's very simple. You see that here in this part of the building, we have everything related to service. We have the restrooms, we have some storage rooms, we have these staircases, probably elevators. Okay, so everything that is small and it doesn't have to be tilted. So we have all this program concentrated in this element here. And then the rest of the building or the rest of the spaces are these 2 spaces. So here we can be more creative because these are huge. Those are huge spaces for a lot of people. Okay, and so we have these shapes, and then the space around these shapes are like corridors or lobbies, so that we can go around all these auditoriums, and then we can enter this auditorium through this or from below. And we have an egg for sure. This was. I think this was the egg time, and we do have an egg here, so we will have the chance to model that egg in the middle of that globe. Anything else? Well, if we look at the sections, again, getting to understand the section is it might be complicated, so that's why we have to go step by step. But I like this section because probably this is made with, or this is drawn with Revit, and here we have grid lines. Without grid lines, it's almost impossible to understand this building. So first we need to set the grid lines, and those grid lines are related to structural elements. Okay, so first we have to fix this grid, and then on that grid we will have structural elements, and finally we will have this envelope. But well, we will get to know this, and this is the final outcome of this exercise. So at the end, you will have to create nice renders from the outside, where you can combine this with section perspectives, or with sections and plans. So that would be like a final panel of your final presentation. But first, we need to understand the building, because it's not, since it's not a building that we can repeat, the first floor, the second floor is the same, the third floor is the same. No, here floors are completely different, and we have to approach this building from a 3D view perspective. So we can't understand this building just by looking at the plans. We need the plans, but we need to move and we need to see this building from outside, so that we can understand the volume. So here we have this. I think there's another PDF with different information. Well, this building is located here in the Netherlands. It's in Utrecht. I thought it was in Rotterdam. In Utrecht. Interesting. And here we have the structural engineer, which is important in these kind of buildings. Oh, design 1993, 1995. I thought it was before. And it costed 10 million euros. Well, almost 11 million euros. This is about $14 million. Quite expensive. And this is in 1944. We're getting old. This is the Educatorium. So this is the first sketch. Yeah, I think it's interesting because just analyzing the building, if you know how to draw something, you understand it. I think it was Einstein who said that. Well, I thought it was Einstein, but it might be another genius. So this is a 3D view. We have window analysis, but we are not talking about. Okay, but I like this picture because, as you can see, this is the street, and here we have an opening. Okay, so this is not the building yet because it's not closed, and with this ramp, you access to the main level of the building. So there's like a ground floor here, but the ground floor is, yeah, we have another ramp here. So there are a lot of ramps. So we have a ramp to go from this level to that level. Then we have another ramp from this level to that level. This is still outside the building. We have this tree here in the middle of this ramp. So the tree is integrated with the building. So yeah, I think it's not difficult, but we have to take some time to get to understand the building. And here we have all the floor plans. Yeah, but this is underground, and this is the first, second, third, the fourth. It's almost the roof plan. So if we understand 1, 2, 3 plans, that would be enough. And then we have the sections. Yes, this is the egg here. And yeah, the egg. Well, those are, by the way, people, if you see a lot of young people taking pictures in this building, they are architectural students coming from different places in Europe, because we all have studied this building. Yeah, this is like the lobby, and these are the structural elements. This is a detail of this folded structure. And yeah, this is something unique. I remember that when he explained this building, although he claimed that this is a very economical building, it's not expensive. It costed 11 million euros in the 1990s. But he told us that, he has recycled everything. So he didn't order all these. No, he took these seats from other buildings that were going to get rid of those seats, and okay, bring me those seats, and he combined different colors. So it's kind of he was a pioneer in using recycled materials. Okay, so now we are used to this idea. Yeah, sometimes let's use recycled materials, but he was one of the first that I know of that used materials coming from other buildings, and then well, he created this nice color combination. Well, the presence of structural elements is very strong. You see that in this space, we have these strong columns, huge columns, and yeah, this is relevant, and this is the first thing we need to understand where these elements are. And yeah, you see that we have these columns here on the ground floor, and some of them go up to this roof. These columns here. Other columns stop here, where this tilted slab is, and this is the ramp. So as you can see, we have the ground floor, but then we start the ramp. This is this open space, and there's a moment in which we have glass, and then we are inside the building. But this is something this idea of accessing the building, this is always good. Okay, so here we are out of the building, but what about when we are moving up through this ramp? Are we inside or are we outside the building? We are outside because we don't have an envelope here, so this is open, but at the same time we have the structural elements and we have a roof. Okay, so we are not in yet, but we are not out. So these kind of transitions, it's always something good in this kind of public buildings, and relating the interior space to the street. Okay, so it's not just like a limit. We are inside or we are outside. No, there should be something there that is between in and yeah. So it's an interesting concept, and it always works when we're designing public buildings. Here we have analyzed, as architecture students, we have analyzed this building from every single point of view. This is a structural analysis. We are not going to do this in this course. And books about this architect and about this building. Okay, so let's start. And we're going to start by working with this plan section. We're going to import this drawing in our Revit file, and we're going to use this as a base, but just as I told you, accuracy is not important in this building. So I want you to learn how to create this, but I'm not concerned about dimensions. Okay, we don't know this dimension. We know that there are doors, but we can create these doors with the Revit doors, because this is quite easy. So we will combine doors, windows, Revit walls, and then we will have to create something different for these shapes. And finally, we will create something different for these curtain walls, because we have to adapt the shape of the curtain wall to the shape of this roof or this floor or whatever this is. Okay, so let's open Revit. And I'm going to use inches or feet imperial units. So we know that 5 feet is 15 inches, and that's all the reference that we need. So if we don't know any dimensions, we will make it up. Okay, I'm not concerned about the dimensions as long as we have a reference, and the reference is that the distance between two columns is 15 feet. That's the only reference that we will need. So we are going to create a new one, imperial construction template. Okay. And first, I always recommend you, before doing anything, just take a look at manage. And let's see the project units. So here we have square feet, the distance is in feet. Okay, so we're going to use imperial units. If you want to change, you should select here meters or inches or whatever. Okay? So we're going to use this default. That I think we can. I think we haven't done this yet. So we're going to change location. Okay, because this is not in by default. We're in Boston, Massachusetts, but this building is not in Boston, Massachusetts. This is in Utrecht, in Netherlands. Utrecht, Lander. Are you sure this is the? No, we're not in Mozambique, but maybe there's another Utrecht there. Netherlands. Okay, I think Revit doesn't know anything about geography. So we will go to the Netherlands. And where is Utrecht?
I think I saw it north.
Yeah, but I. Error. Let's say Amsterdam. Maybe there's another Amsterdam, Mozambique. Well, there's something here. I click Amsterdam, and yes, I want Amsterdam, New York. No, I want Amsterdam, Netherlands, but it doesn't allow me to pick the right option here. Okay, and now I can type Utrecht. Utrecht, Netherlands, here. There we go. And okay, we will click OK and just check that when we click here, yeah, we're in the right place. No, we don't. Okay, so this is location. This is another thing that we haven't done it before, but this is probably the first thing you have to do. You have to set the right location, and usually it works. If you type Utrecht, Netherlands, it doesn't go to Mozambique first. But anyway. So we're in the right position now, in the right location. We can do something different here with the sun path. Okay, with the sun path, we can orient the building. Where is the orientation of this building? That's a good question. So do we have a north sign here? No, we don't. Okay. I'm sure that in one of the documents here, we should have the north sign. Maybe plans, we don't. Okay, so this is north. This is north. Yeah. And this is south. Probably we will have to change because this is the north elevation. I don't know. I'm used to looking at that building in this direction, and this is north, and this is south. Well, we can switch. Okay, so now that we know where the north is, we can go here. I can hide the sun path, and I'm going to insert a picture, and I need to go to desktop, this one, plan section. Okay, and now I can place it here. As I told you, this is the north and this is the south. On the other hand, we have the section here. Okay, I will rotate this. So let's rotate 180 degrees. And now this is the north and this is south. Okay, so it's well oriented now. And we know that this distance now it's 5 meters or 15 feet. So let's work with a model line. So we will get this auxiliary line. And I'll copy this. Copy. Here. Okay, kind of. And now what is that distance? Let's go to annotate. Okay, this is annotate line. It's 12 feet. And we know that it's 5 meters, so it has to be 15 feet. So we can create another model line, type 15. Okay, so now this is 15 feet, and now we have to scale. If we select this picture and this line, we click scale here, and now we go the first point, the second, and the third. Okay, so now these lines are 15 feet. And it's, yeah. So this is all I need. And now I'm not concerned about the rest because I'm tracing the building depending on these reference lines. Okay, I'm going to do it again. And I'm going to make it even smaller. So imagine that I have this. Okay, so I have inserted this file here. And the only reference is that this is 5 meters. So I have to model a line here. Here. And then I can copy this here. And this distance now, okay, now it's 8 feet and 7 inches because I have changed the scale of this. And I want this to be 15. So I have to create a model line now with the right dimension, 15. And then I select scale. Scale, I select the drawing, I select this line, click enter, and now I have to select 3 points, the first, the second, and the third. And now this is 15 inches. You get it? Nicholas?
Yes, I got it.
Okay, sorry, I deleted this accidentally. But now those are auxiliary lines, but I want something, because now I want to work with a grid. I told you that the grid is important. So I'm going to create architecture, grid, and from this point, I'm going up, and then I select block. Yeah. I want to go all the way down. And now I can get rid of these auxiliary lines, because I know that the second, if I copy now this grid line 15 feet away, so this is the second grid line. Okay, the only thing I can understand here is those are the big columns that I saw in this document here. Okay, in this ground floor, we see these huge round columns, and this is what we are looking at here. Okay, is there a grid? Well, if there is not, we have to make it up, because, for example, this column is not matching this grid. Okay, in my drawing, this column will be here on this grid, because it makes much more sense. These two, well, they are too far away to think that the three columns are on the same grid. So maybe there's an angle here. Let's copy this. We don't know the distance, so let's place this kind of in the middle of this, and let's make sure that we are, yeah, this is 1, 2, and 3. So if we copy this, that will be the fourth. From this point, do something here. And then I'll copy this here. Okay, so these two columns will be, yeah, so I see that there's a line of columns here, 1, 2, 3, 4, 5, and even this partition will belong to this grid. And there's another grid line here. Yes, so I can copy this here. And yeah, so this is a grid line with a lot of columns, and this is another grid line with a lot of columns here. And I bet that I have found the rule here, because you see that here we have 1, 2, 3, 4, 5, 6, 7. So I bet that all these columns are the same distance, and they are aligned to this one. Okay, so eventually I will find a pattern here, and I think this is the pattern. And I think the distance between these two grid lines will give me this, yes, and this one. Okay, now I'm creating my own drawing. It's not what I have imported or inserted here. Now it's my drawing, and I'm making decisions. And I have made the decisions that the distance between this, and this is the same. Is it the same? Well, I don't know, but yeah, I think this is not accurate enough. I'm not importing an AutoCAD file. I remember that for the midterm, we imported an AutoCAD file, and the goal was to be accurate with this AutoCAD file. Now we are importing an image, and this is not accurate. So we have to make our own decisions. If I don't know a measurement or the distance between this and this, I'll make it up. But I can't stop moving on. So if I don't know a dimension, I can say, "Oof, what do I do? Do I have to go to Utrecht with a tape and take this measurement?" Doesn't make any sense. So let's make decisions quickly. And I think this is a good decision because at last I have found a pattern. So all these elements, all these grids are at the same distance. And I would bet that these are at the same distance as well. So that should be half. So I can always create a model line here, and I can copy this grid line from this point to the middle. But now this is not 9. We have to be careful because, well, although, yes, so there's something here. Okay, so we have this, all these lines are connected to this grid line here. So I would name them again. So I would name this 6. Oh, we can't have the same. Well, if we have this, we can say this is 5, 5, 5. Okay, so this is 5, this is 6, and this grid in the middle is 5, 5. Why? Because we don't have these thicker columns. So we have columns here, but they are not as important as these ones. And for this one, I can name them 6, 6, and this 7, 7. So I'll do this. Okay, so this is 6, 6 now. And then I'll copy this one. Seven, 7. Yeah, it might be. Yeah, why not? And do we have any other columns here? No, we don't. So we don't have columns in this part of the building. So I think we are done with the vertical grid lines. Now, what about the horizontal? In horizontally, I think it's clear that we have a grid line here. All these columns should be aligned. All these columns should be aligned as well. And I think we have another line here. And we have another line here and there. And here we have like a diagonal. That, yeah, look at this ramp. This ramp is a diagonal and it's aligned to all these columns that I have here. Okay, so let's start with a horizontal grid line. And that will be A. Here we have another one, so I will copy this. Move it here. This is B. Now, I tend to think that distances are the same. So I'm going to copy this one. Yeah, so it matches here, kind of. The C. And now this, I don't know. Okay, G. And finally, this one. And I think this, if I copy this at the same distance. No, move this here. And Do I need anything else? Well, probably this line, this facade. Here. I don't like this page. I will call this A0. And I call this F0 so that I know where the building starts and where the building ends. And finally, I've got this. Instead of a grid line, I'm going to use a reference plane. Okay? So I'm going to use a reference plane that goes diagonally here. And I have to make to name this reference plane. Let's say diagonal. I'm not good at naming this. Okay, so I think we are done with this. We don't need anything. We don't need anything else. So we can even delete this drawing, and with these structural elements, okay, we can make up whatever we need, because the most important thing is that the structural element now they are at the intersection of these lines. Now we need to do the same with levels, because this is the level 1 by default. Well, there are a lot of levels here. Level 1. I'm going to get rid of all those. Okay. I just want level, and level 1 0. No, I name this level 0. And here we have all these grid lines from A0 to F0. So I need to find out where is level 2, level 3. So what is the distance between these two elements? I have taken this. So if this is the ground floor, I can create auxiliary lines here. So I can have a green auxiliary line here, and another green auxiliary line here. So the distance between these two lines should be around 12 feet, because in all buildings, 12 feet is a good distance for two different floors. So let's annotate a line. It's 10 feet and 2 inches. And what about if we copy this one here? Is it the same distance? 9.9. And finally, this one. Oh, and I have the top is this one. Okay, so those are the levels. I will annotate a line. So from this, second, third, fourth, and fifth. Okay, so this is 10, 10, 4 inches, 9, 9 inches, 10, 2. If I click here, EQ, now we have this average distance, which is 10 feet and 1 inch. This is what I'm going to use. So level 2 would be at 10 feet and 1 inch. And that would be level 10, 1. That would be level 22, because that would be 20 feet and 2 inches. And the next one would be at 30 feet and 3 inches. And I want to name this 33. And do I have any other level? No, 1, 2, 3, 1. So this is level 0, 10, 20, 30. Oh, I need the last one, which is 40. 40 and 4. I have created a grid for levels, and now I have the distance between levels. But if we look at the building, it might look complicated, but the distance between the floors is the same. Okay, so at least I don't have different heights in different floors. And this is a double volume, and this is another double volume, so it's not that difficult. And I'm not going to, I don't think I need to trace anything. I will use some reference lines, or I would use these auxiliary lines, but I don't need to import here the section to make up this profile, because I have the reference lines. And since I know that, yeah, so here we have this element at this point. If I extend this to the section, okay, so with these reference lines, pretty much I know where the flat roof starts and ends, and I know where this slope starts and ends. And yeah, so I don't think I need to import this in the section. If you feel more comfortable, you can do that, but I won't do it, because now I can get confused because of this drawing. So I need to understand the building, and once I have understood the building, I don't need to trace it anymore, because I know what this is about. So I know that we have this shape, and then we have that shape here. Okay. Using the 3D view. Oh, in the 3D view we don't have yet. We haven't done anything yet. So we're just creating levels and grid lines. So we don't have a building yet. So I know that you want to start the building as soon as possible. Let's do it. And I'm going to use the south elevation. Okay, let's use let me see. Yeah, this is the north elevation. And I don't know, I'm always, when I look at it or when I imagine this building, I always imagine this north elevation. So I think we are going to open the north elevation here. We have all the grid lines and all the levels. So this is 1 and this is 8 on level 0. Yeah, this is 1 and this is 8. Okay, we can see that. Okay, I think we need 2 more reference lines. I can copy this because this is the limit of the building. And so I can call this 1, 0, the same. So the building starts here. And I think there's another interesting point is where the slope starts or the ramp starts. I think it's here. So I'm going to name this 8. Yeah, I think the ramp starts here and this ramp goes to, yeah. I think this is a good reference line from the north elevation. Okay, so the ramp will start here and then it gets up to which grid line? Up to this between, okay, between 55 and 6. Okay, it goes from 80 to something between 55 and 6. Then we go horizontally until grid 4. Okay, let's do that. So we start here, this grid, 80. I'm going to do this with an auxiliary line. Educatorium. I'll pick a plane grid A. And now I know that this ramp starts here. It goes somewhere between 55 and 6. And then I know that I go up to the 4. Is it true? So this is 4, yes. And this is something between 6 and 5. Yep. And now we have another slope, and that goes up to this point, which is grid number 1. So from this point, I go up to here, grid number 1. Then I fold this up to this level, And then I go all the way up to grid 8. Okay. So I know from this point I have to go up to grid 8. And here I need like, I can pick this line, this start radius in arc, because this is like an arc like this. Okay. I think I have half the building done with this. I think we're going to finish this building next week, not May. Well, with these kind of things, we cannot use walls, roofs, floors, because as you can see, this is a ramp, and this can be a floor. This is a floor, but now what is this? This is a wall. Is this a roof? Is this a roof or a floor, or what is this? So I'm going to use a component model in place. Okay. So in a component model in place, let's say that this is a wall, because I want this to be made of concrete. If we select extrusion and if we pick lines, all these auxiliary lines that we have already created, this one, this, and this, are we, I've changed my mind. Cancel this and cancel. Let's try a roof by extrusion. We have already used this tool when we created like the stairs, I remember. And now I'm going to pick lines. So I'm going to pick this, and this. See what happens. Perfect. Don't you think so? Did you do this, Craig and Nicholas?
Still currently working on it right now.
Yeah,
Do you have it?
I'm working on it.
I'll do it again. I want to discard roof. So first, the secret to this is to create this shape here, the green lines. And since I have the grid, I can follow but I need to understand the building. That's the only thing. So I have the level here. The only thing is that I have to look at this. I'm going to copy. Well, no, I can't copy this. So we know that this ramp starts at this point. Okay, so this is the starting point of the ramp. And this is level 80. And it goes all the way up to, yes, so there's something here between these two grid lines. And these two grid lines are 6 and 5, 5. Okay, so the ramp goes from level 80 to here in the middle between 5, 5 and 6. So then I go to the north elevation, and I know that I have to start this auxiliary model line in grid 80, and then I have to stop somewhere here in the middle between 5, 5 and 6. There you go. Now we have to go all the way So it's horizontal up to this line, and this line is 4. Okay, so I go horizontally up to 4. And then I know that I have to go, there's a slope up to line 1. Okay, because in this line 1, we know that this slope ends, and then we need this shape here. So in the north elevation, I'm starting from this point up to 1. I don't think, yeah, I have to draw a line for this one. Okay, then this one is quite easy because it goes from line 1 to grid 8. So we go from 1 to 8. And finally, I need this. When I did it before, I create this start and end radius, but this is not a circle. If we look at this, okay, so it's not a circle, it's a different shape, and it starts here and ends there. So I'm going to do something different. What can I do? This with tangent. Okay, I'll try this. Yep. There you go. Don't go crazy with this shape. Okay, so if you want to create a circle, do it. Don't go crazy, but I think it's not a circle. Yeah, it's not. But we don't know that shape, so it doesn't matter. Okay, so once we have this this green line, now we can create a roof by extrusion. We pick the lines, all these, 1, 2, 3, 4. We click OK. There's the roof. Well, by the way, now we have to move it to the right place here. Well, now you see that basically the building, it's two folded pieces. We have this one, the one that we have just done, and then we have the other one, which is this. It's easier because we don't have any slope. It's something straight, and it starts on level, this is level 0, level 10, level 20, and it goes up to level 40. And we can, yeah, maybe it doesn't match here, but I can make it up. So we can go from this grid line, which is the grid line 5, up to the grid line 80. So we are in line 5. Up to 80. line 5 again. And now I can do another roof by extrusion. I can select, I can pick, well, I have to pick lines. One, two, three, and where can I? No, I don't want this. Valid. I'm going to do it again. So I'm working with model line from grade 5 to this one. Now I create a roof by extrusion, pick lines. Why can't I pick the green? I'm going to hide this in view. Okay, and now I can pick roof by extrusion, pick lines. What is this? Okay, if it doesn't work, I will create a roof by extrusion, but I'm not picking lines. I'm just doing this. I finish, and we have roof. And on level 0, maybe it doesn't work. Let me see, level 10, level 20. I have to have here. Do you get it? Remote students, do you have any questions?
Nope.
I mean, this is the project. I mean, when we are looking at this, the first thing okay, how can I do that? Where do I start? So just by, and this is a lesson that we have to understand as architects. sometimes we are not able to create something like this because we don't know the basic rules. And the basic rule is a grid. And then we have to count. Okay, so where this line starts here and ends there. Okay, so 1, 2, 3, 4, 5. Now this one starts here and ends here. 1, 2, 3. So it's very simple. It's like it's less like a kid's game. We have a grid and then we connect dots. And this is what this complex architecture is about. It's not something that you have to. You need a spatial vision to create it. No, it's just connecting dots. And what dots? Okay, we need a grid, and then we are connecting this dot to this one, and then this one to that one, and then this. And by connecting dots, we create this kind of thing. So we get to understand this when we analyze good buildings. That, yeah, it might seem very complicated, but it's not if you understand the basic rule. And what is the basic rule in this building? The grid. And then, yeah, so we have a floor that becomes a ramp, and then it becomes a roof. But if we understand the grid, we can just, and we don't even need to trace it. It's just like, okay, so I make up this grid, and then I connect dots. This one to this one to that, this, and then this, and a little bit of imagination, you end up having what you are looking for. Are we done with this? We are not, because the building is not that simple. Because we need to understand the building, okay? But this is the starting point, and with this starting point, now we can start doing a lot of things. For example, the columns. Okay. These columns, if we look at the section of the building, or this elevation, you see that these columns start here on level 0 and then go up to this roof. We have already created that roof. Okay, so this is the shape that we have created. So now it's quite easy if we create those columns and then we attach those columns to this shape. So let's do that. And again, it's about connecting dots. We have a grid, and these columns are at the intersection of two different grid lines. So I can go to architecture. I can insert architectural columns. We have rectangular. Well, those are round columns. So I would go to insert, load family, and in English imperial. That's an issue because we don't have these families here. Is it in Spanish? No. Is it in French? Okay. I need to bring round columns because by default, and I don't think, can you try to load a family? Do you have anything else than structural precast?
You have to download them separately on 2021.
Yes, I know, but no, I'm asking those guys here. So do you have here anything other than structural precast in this insert load families?
Yeah, I was able to download. I have Revit 2021. I was able to download that.
But you're not working with a computer lab, so you're working with your own laptop. Oh, okay. Okay, so this is something I have to do on these laptops. Yeah, I have to go to the Revit 2021 site, and then I can download it. Okay, if you have round columns, insert a round column, but if you don't, we can just work with the architecture, and well, I have a square column here, so make sure that it's at the intersection here.
So if anybody's working with 2020, it's in mine under columns. There's round columns.
You have round columns.
Yeah, but I'm using Revit 2020.
Yeah, because in 2021, you have to, it happens with 2021, you have to download families. So you have to download the software, and then when you are running the software, you have to download the families. In Revit 2020, everything is included. I don't know why. Well, people make our lives more difficult. But I'm not going to, next time I will have round columns here, but I have to make sure that all the computers in the computer lab, they have these families in the event that you want to come here to. But anyway, I'm going to do this with the square, but if you have round columns, do it with round columns. And for example, there are some columns here that are not, they don't belong to that grid, but those columns, we can assume that they are at the intersection this here. So I'm going to do this, architectural, here, here. Oh, I think this one. Okay, I'm doing this, but I want to see where those columns are. Okay, so they start on level 0, but now we have to attach. So I have to select all those. And attach to this roof. Okay. With round columns, it will look much better. So that's it. It's that simple. We have created something that it looked like very complicated, but if we know the basic rule, and the basic rule is the grid. So if we know the grid, then we can do anything else. And yes, so there are some columns that are out of the grid. Well, because he felt like, okay, so the grid is too simple. So let's introduce this diagonal line to make it more. The only thing now, because we can start tracing these walls, but we need to find out where these walls are. So we will leave this for next class. You don't have to submit anything, but make sure that at least you have this by next Tuesday. Okay, so it's quite simple. Once you have the grid and you create this roof by extrusion, we have this shape. And next Tuesday, we can start working with other features with Revit. But this is a good starting point to work with Revit next week.